Hi guys, and welcome to another video. Today we're going to be looking at trigonometry, theory and a sketch exam type question. Now I call this a type 1 question and it's from the November 2010 paper 2. Now a type 1 theory question dealing with sketches involves us knowing our unit circle, the Cartesian plane and our formulas. So let's read the question and go over it. I'll explain to you. Given tan of alpha equals to 3 over 4, where alpha is between 0 and 90 degrees. Now here we have to know our theory. For example, we have to know where tan is positive or negative in our unit circle. And also we have to have a knowledge of our angle in the unit circle as well. So let me introduce to you the unit circle. So therefore, in our Cartesian plane, we would have the following. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. An acronym that we learned early on is that all trig ratios are positive in the first quadrant, and the reason for that is because x is positive in the first quadrant and y is positive in the first quadrant. And if x and y is positive in the first quadrant, we need to know that, remember, r is always positive. And if r is always positive, then all trig ratios will be positive. Now quickly, let's just establish our trig ratios very quickly. So if I have an angle, a reference angle of sine theta, the formula is y over r. Cos of theta equals to x over r, and tan of theta is equal to y over x. We can also say sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. But since we're working in the Cartesian plane, we will use x, y, and r. So all trig ratios will be positive in the first quadrant. Only sine will be positive in the second quadrant because y is positive and r is always positive. And in the third quadrant, tan is positive, and the reason for that is that y and x are both negative in the third quadrant, so a negative over a negative is positive. And then lastly, cos is positive in the fourth quadrant because x and r is positive in the fourth quadrant. So very quickly, why do we call it a circle? Well, there you go. So if I had to have a reference angle which is theta, remember now that will be r, that will be x, that will be y. Okay, so that's basically our unit circle. And we can now complete the formulas. Theta and 360 plus theta, 180 minus theta for the second quadrant, 180 plus theta for the third quadrant, and 360 minus theta for the fourth quadrant. Those are our reduction formulas. And we'll come back to that a little bit later on. Now, let's get back to the question. It says tan of alpha equals to 3 over 4, where alpha is between 0 and 90. So between 0 and 90 is the first quadrant, which means that the sketch has to be drawn in the first quadrant. Remember our angle, all angles start from the positive x-axis and they go in an anti-clockwise direction. So tan is 3 over 4. There's tan, so the y value is going to be equal to 3 and the x value is going to be 4. So 3 over 4 opposite over adjacent. Now we'd have to calculate the hypotenuse or the r value by using the theorem of Pythagoras. So r is going to equal to 4 squared plus 3 squared. And don't forget, we use the theorem of Pythagoras to do that. That's equal to 20 5. So therefore r is the square root of 25, which is equal to 5. Now remember, this is very important. R is always positive. In all quadrants, R is positive. What I want you to do is make sure you know the values or the signs of x and y in all the other quadrants. So now we can answer our questions. Our questions are as follows. With the use of a sketch and without the use of a calculator, calculate sine of alpha. So 9.1. Sine of alpha, we know it to be y over r. Now we don't have to write the formula down, but I just want to illustrate to you that it's now just a matter of substitution. Y is 3 and r is 5. So it's 3 over 5. The next question is cos squared of 90 minus alpha minus 1. So we're going to reduce this cos squared of 90 minus alpha minus 1. So for 9.2, cos squared of 90 minus alpha. So what are the ratios that will pop up all the time? The functions will be sine of 90 minus alpha is equal to cos of alpha. Cos of 90 minus alpha equals to sine of alpha. Therefore, cos squared of 90 minus alpha is going to be sine squared of alpha minus 1. So we are left with, so we reduce cos squared of 90 minus alpha to sine squared of 90 minus, or sine squared alpha. Cos squared of 90 minus alpha is sine of alpha. So therefore, cos squared of 90 minus alpha is sine squared of alpha. Let's substitute once again. What is sine? Sine is y over r. And my y value is 3. So it's going to be 3 over 5 all squared minus 1 equals 2. At this stage, you may use the calculator. 3 over 5. Now don't tell anybody I told you this. 3 over 5 all squared and minus 1. For exam purposes, remember that we're going to get marks for the reduction, the substitution, and the final answer. So therefore, the answer will be minus 16 over 25. Minus 16 over 25. And if you don't want to use the calculator, you may do it manually. It's not difficult. Let's look at the last question. 1 minus sine 2 alpha. 9.3. 1 minus. Now, sine 2 alpha is a double angle, which will expand to become 2 sine alpha cos alpha. Now, the reason that we expand this double angle to a single angle is because, as you can see, my sketch is in terms of a single angle. So I have to now use the expansion for my double angles to write 2 sine alpha cos alpha. So therefore, it's 1 minus 2 sine alpha cos alpha. And now I'll just substitute 1 minus 2. Sine alpha is y over r, so that's 3 over 5. And cos of alpha is 4 over 5. Remember, cos is x over r. Now let's put that in our calculator. 1 minus 2 into 3 over 5 times 4 over 5. Let's get that. 4 over 5. Now that will equal to 1 over 25. So it's important for us to make sure that we learn all our expansions and learn your unit circle. Make sure that you understand it as well. Let's just put in here 0 degrees, 90 degrees, 180, 270, and completing the revolution 360 degrees. Learners, if you haven't subscribed already, hit that subscribe button, share this content as much as possible, and I'll catch you in the next video.